Alright, Booleans, self-intersection points, normals, and face direction. Okay, so all those great things covered in this video. This is a cube. The outside is dictated by a thing called normals. Okay, normals face in one direction, and like programs like Blender can emulate the fact that they're facing in both directions. Alright, to show you what I mean, I am going to just employ a face. So add mesh plane. Okay, so if I rotate around here, you can see both sides. If I hit N on the keyboard and go down here to display backface culling, backface culling allows you to see through the one side. Because it doesn't emulate a two-sided mesh. And this is how a 3D program sees the mesh, is because of that normal, especially ripping programs or slicing programs. So another way to see normals in their direction is like this. If you hit Tab to get into component mode and hit N, you can go down here to normals. Okay, and then I turn the normal size up and you can see the normal direction. Now any time that you have, let's say, an object with a flipped normal, like this one, I'll take this face and I'll just flip it. Over here I have flip direction. I have this. Now if a 3D program, like a slicing program, sees that, it will render it inoperable. It won't understand that one face, and it will have errors. Now this is good on a little cube. It's an easy fix. I can either flip the one face, or I can go in here and hit A to get all components and say recalculate. It'll look at the overall mesh, the outside global area, and dictate, well, direction of normal should be this way. Okay. So that's an easy fix. But if you have an object that has like tons and tons of polygons and only a couple faces are flipped, then you have issues. Then you have to use programs like Netfab, and even Netfab sometimes has problems in certain areas with flip normals. Flip normals also hurt when it comes to things like Boolean operations. So let's look at that. Booleans. Alright, and directions of normals and how they are affected. This is one of those things that if you're new to 3D printing and new to modeling, normal direction and Boolean will just, you want to rip your hair out sometimes. But it's not that bad. Let's look at the underlying problem here. So what we have is a cube, and I'll shift D to make another cube. And I'll take these cubes and I'm going to offset them a little bit. And then I'm going to take the bottom cube, hit Tab to get into component mode, and I'm going to hit A to highlight it. Okay, then I'll go over here to flip the normals. Also, I want to push this one into it just a little bit. So there's another thing that we have to worry about, is self-intersecting. We'll get into that here in a little bit. I'll take these two pieces and object join them together. Okay. Alright, well, if we go over here to hit check all, this is the 3D print module. It's located under user preferences. Under mesh, you can turn it on by going to 3D toolbox. Check there. You'll see that it says inset faces set to 4. So these are the inset faces we have to worry about. In some 3D slicing programs for 3D print, see those. Some overlook those. So Slicer is a program I use all the time, and it overlooks it. It's a beautiful piece of software. Now when I had a replicator, before I gave it away, it did see this, And so, you know, like I had to load up Makerware just to look at different issues between the two pieces of geometry. Now, I have also an overhang. Let's go back into Boolean. So what we're going to do is go into Add Mesh UV Sphere. And I'll hit S on the keyboard and just kind of drag it across to make it a little bit smaller. This is called Sphere 001. And when I go into Boolean, I can choose to difference, which would cut this into this. Z on the keyboard allows you to see the wireframe, so you can see how it's cutting. And if I take this object and move it down to this one, it will sort of union it together. Okay. Now it's failing because the fact is the normals are flipped. Also, if you drag this piece into both of them, it will fail utterly. To fix this, again, what you'd have to do is look at where the normals are and how they are. So I would drag this piece out, hit Tab, Z to get back into it. Since I have Backface culling on, like shown in the last video, this one right here, I can see it. I can go L on the keyboard and then just flip those around. Then I can go back to the ball and push it into the geometry. And you'll see under Z, it's actually making a good cut. Alright, now, if I go into here in object mode, and hit apply, I now have this piece of geometry, and I can take it and hit over here, check all, and it will give me some issues. 0 faces and overhang. Well, duh, it's going to overhang because of this right here, and 0 faces. So let's select the 0 faces, find out where those are at, because that's a common problem. Now for faces, I can use the dissolve feature. Up here, I have dissolve faces. And there's another way to do this too, so let's go to L, then A to deselect. Let's go back down to check all, and I still have 0 faces, so we'll switch over to the other method I use. I go to the points or vertices, and then I'll go over here to dissolve or remove doubles. Okay, you can see there was a change, but it was based upon overhanging vertices that were right on top of each other anyway, so it didn't change the overall form of the mesh. And since I used the isolate feature down here, that was a nice thing. It was only working on those 1 vertices. So let's go over here to check all. I like to have everything deselected. There we go. Now all that is gone. So you just have to be very wary about when you use Booleans, especially with intersecting faces. So here's another thing that you have to be concerned about. Like, let's say I add a mesh cube. Make sure you're in object mode. I'll just get rid of this example. Then I'll add mesh sphere. A little bit slower right now because I'm used to using the Maya preset for Blender, but I find it kind of unfair to teach that because it's a preset. So I'm just sticking to Blender defaults. And I'll tell you what, it just makes me, it's just a tad bit slower when it comes down to this. So I scaled that in just a little bit. Alright, now if I wanted to 3D print this, I'm going to duplicate it. This would be for people that have no issues whatsoever with intersecting geometry. Like if I just wanted a beta, wanted to be able to print it, I would just use Slicer to print that. If I was using like Makerware or wanting it to become universal for other people to print it, I would have to take object A, and then I would have to go into here to Boolean, find object B, which is sphere 01, and do a union on it and apply it. Now this is a very 3D printed part. Now that seems very easy to do when it comes down to a part like this, because it's a super simple part. So let's look at a complex part. Here's a part that I made for one of my cases, and this is great for me. This one on the right hand side will print just fine, but if I have to get it out to a production run or put it on Thingiverse, you notice when I hit L, it highlights just individual pieces. So these are pieces on top of each other, and this is just caused from like beta modeling, okay, in Blender. So I want to get something like this out. Well, I can do that because I have software that does it, but the problem is that software is very expensive. So I use in my workflow a program called ZBrush, and this is because I model like this that I have to do this. But I use ZBrush anyway because I really can stylize my model, and I'll show you in a next video or a video how I can like bring a phone case in, and I can totally go into it, sculpt it, and then print it out. You know, it's this beautiful piece of software. Now I've been using it since I was a kid, so what happens is I get free upgrades for life when I use the software. You buy it once, so I bought it for $50. Now it's $700, just to show you the stock value that went up. I'll export this as an OBJ, and I'll put this on my desktop. I'll just call it fix. Okay, I'll go into ZBrush, and it kind of looks like this when you first start. The software has a huge learning curve, but for what I'm about to show you, it's very watered down, pretty easy to understand. And watch it crash because I was talking good about it, right? That's how it always is with software. It does function on, I think, OpenGL. So if you have a program that has DirectX driven and you switch between DirectX and OpenGL too much, it will crash. That's the only bad thing about it. Very rare occurrences, and just like that. Of course, it happens with a video. Okay, so in here, starting out fresh, I'll just go to Lightbox, just go to Tool, Import, and I'll import that piece of geometry. I'll click and drag it out and hit Edit, and then what I'll do is I'll make it into a dynamesh. Dynamesh makes a very uniformed piece of geometry that has no internal intersecting geometry. So here, under Geometry, I can go to Dynamesh and turn this up. And this dictates the resolution, so you don't want to go too far with it unless it's a very complex piece, or it will take a while. So I'll make two different forms here to show you 3D print wise. I'll call one the editable form, which has good topology, and I'll call the other one a decimated form, which is kind of a reduction of polygons. Okay, so it's a dynamesh, and I can go to subtool and hit duplicate. That way I can do both. Okay, so now I have actually two pieces here. I can turn one off. This one, I'll show you the decimation form here in ZBrush. So what I'll do is pre-process the current piece, because right now this thing is made of millions and millions of polygons. That's how dynamesh works. It just gives you a very uniform piece of geometry, but it's huge as far as poly structure wise. I'll turn on this Polyframe so you can see what's going on, and I'll go into the plugin and say decimate. I'll say 2% and hit decimate current. I now have a perfect piece for 3D printing. I mean, this is the best piece that you'll find because it has no flaws, it has no internal problems. It's awesome. The problem is it's triangles. So if I wanted to edit it after the fact now, sometimes I have to edit it after the fact. It's a hard thing to do, and you can't sculpt on it. And sometimes I do sculpt on things. So that's where I go to the other one. This one allows you to go to geometry and go to ZRemesher, and I'll use adaptive and hit ZRemesher. So this looks at the form, gives you really awesome topology that can be divided after the fact, and then if you wanted to stylize a piece, this one would probably be a poor example of stylization, but if you wanted to stylize it, you could. A phone case would be a good example. So here we go. So now it has really good topology, and now I can divide it further, and I can go in and say, well, you know what, I like this, but maybe I just want to add some bumps, or maybe I want to add some texture. You know, it's just crazy what you can do here with this program. I won't go into all of it and what it can do, but yeah, you can do some awesome, really funky things with it. So if you wanted this as a 3D printed part, again, you would have to, after you add all the detail, you would have to redecimate it to get that detail back into a usable 3D printed form. So I'll show you that also. Now when you get so many polygons, the decimation phase does take a little bit longer. Alright, then I can go to the plugin and do another decimate current to 2% and look at the overall structure, and sure enough, that would be 3D printable. To get these out back into Blender, you can just hit export. And it will export whatever subtool you're on. So it'll export this one, or it'll export this one. It won't export both at the same time unless you merge them together by hitting merge visible. But then they'll be on top of each other, and you don't want that. So that's a program that I use in my workflow. Again, it's expensive, but it's pretty much worth it, and it gets out really good geometry after the fact. Now, hopefully that kind of shows you some of the things you have to kind of work or look at as far as Boolean geometry and how you kind of look at flaws in your modeling and how to fix them. But really, there's a lot of issues that come up in the heat of battle that, you know, you just gotta, that toolkit that's in Blender is pretty amazing. It's good at looking at things. It's not really good at fixing things though. The other thing that you can use that I use all the time is Netfab Studio Basic. I love this program. I've had no issues with it, but I guess there is something in here that allows you to go in, if you had the Pro variation, to look at for collisions and take out those collision self-intersecting parts. So that's if you wanted to spend the money on the program. It is a good program. I prefer ZBrush though in my workflow. So I can't afford both. So I hope you enjoyed this. This is a little just demonstration of different quirky things you have to look out for as far as 3D printing is concerned. So enjoy.